Okay, we are talking about periodic functions, okay? Hopefully by the end of today's lesson, you'll be able to determine, you know, what makes a function periodic, as well as how to find the period of a function. So, the period of a function is the horizontal length of one cycle, the horizontal length of one cycle. Now, a periodic function is a function that repeats a pattern of y values at regular intervals, okay? So if you look down here in this diagram that's given to you, you can see that it's basically going to continue this up and down pattern throughout, okay? That's what makes something periodic. Okay? So then, since if you have a curve that repeats the same pattern back and forth, the same y values, like it rises up to the same y value, drops down to the same y value, and continues to keep going, that's what's an example of a periodic function. And the period of that function is basically where the curve starts to repeat itself, okay? If you look here, it goes here, and then after this point, it's going to continue to go down and back up, and so on and so forth, okay? That is what represents one cycle, and then from here to here, from this point to this point, basically lets you know what exactly is the period. How long does it take for the graph to repeat itself, okay? Does everybody understand what I mean when I say how long it takes to repeat itself? Okay, let's take it in the real world. How many days are in a year? Okay, we're taking out the leap year, 365. So after December 31st, what day comes right after that?
January.
And you continue throughout the year. Once you get to December 31st, what happens after that? So even a year is an example of a periodic function, okay? Because you basically go through the same set of days, and then at one particular day, it's going to start back over, okay? A month, this can more or less, okay? You think about your months that are like 31 days back to back. Anybody know which months are 31 days back to back? Nobody think of which months? July and August. Okay, so you got July 1st, it goes through 31 days, and then you start back over on day 1 of the next month, okay? So that's also an example of a periodic function. A decade is how many years? 10 years. So you know you go to, let's see, 1970, 1971, 1972, all the way to 1979, and then it starts to repeat itself back at the year that ends in a 0, and it continues to go on from there. A week. That's another example of periodic function. Do you see what I mean? After a certain number of days, after a certain time, it's going to start to repeat itself, okay? Even time is an example of a periodic function. Start at midnight, you go to noon, and you come back to midnight. And then you go back to, you see what I mean? So everybody understands what I mean by the period? Okay? Everyone who has hands on their faces, go ahead and drop them, sit up straight. Okay? Remember, you got an option to come to school today. Okay? So since you're here, you might as well do the best you do, right? So, what is the period of this function? Now, I know you probably can't see it on your copies. You probably can't even see it that well. Here's an example of another periodic function, okay? And then the second graph that's on there, the one that's to the right, is supposed to be like highlighted right in here. Yes, and it's supposed to kind of show you that, okay? Here's an example of a periodic function, and here's how you can also tell what the period is. You can go from max to max, or from min to min. How long does it take to go from one max to the next max? What is the horizontal length between these two maxes? How long? 4 units. So that means the period of this function would be 4. So after every 4 units, I'm going to be back at a maximum. Okay? So if I wanted to continue this curve, okay, here at 1, I go down, I go back up. This value at 5, I'm at another maximum. If I wanted to draw another cycle, where should my next maximum point be? Where? At 9. So 6, 7, 8. So at 9, I should be back at another maximum. Here's my last minimum. It's located at 3. Where should my next minimum point be? At 7, which is 4 units later. So even if you had to draw another cycle, you could based off of that information. Does that make sense? Okay. What about this function? Is it periodic? And if so, what's the period? No, and remember, period will represent that horizontal distance. But look back at that definition. What makes something periodic?
Y value.
If it repeats the y values, are these y values repeating? No, they're actually increasing. So is this an example of a periodic function? No. Okay, now if it was something like, this, then that would be periodic because I'm basically alternating between 2 and 0, 2 and 0 all the way through. Then I can figure out what my period is for something like that. If it was going down, that would not, it would have to go horizontally, not vertically. That's a good question.
Later on, so we're gonna have limits for these,
Like where it starts and stops?
like 2 and 0.
Yeah, you'll have that that vertical bound, but it's going to be your domain is also going to be continuous. Okay. So any questions on what makes something periodic? How to find a period? Okay. Well then let's look at another two topics. Okay. You have something that's called the midline, which is the horizontal line midway between the maximum and the minimum values of a periodic function. And you have the amplitude, which is half the difference between the maximum and the minimum values. Okay? So if I wanted to explain it a little bit better, the midline basically cuts your curve smack through the middle. Okay? Because it's smack through the middle. And the amplitude is the vertical distance from that middle line to a maximum or from that middle line to a minimum. And it should be equal. Okay? The amplitude. So that distance from the midline to the maximum or the midline to the minimum should be the same. Okay? Look at this example that you have right here. All right? This top line, this top blue line represents the what? Represents the maximum. And the red line represents the what? The minimum. Okay? So the line that basically cuts right through the middle, between the maximum and the middle, is called the what? The midline. Okay? So maybe you're not going to be able to see it up here, but you can definitely see it on your paper. What is the maximum value? 1. And what is the minimum value? -2. Okay? So to find our amplitude, okay? So to find our amplitude is half the maximum value minus the minimum value. Okay? Well, you guys said the maximum value was 1, and our minimum value was -2. 2 negatives make a what? Positive. So 3 over 2, or about 1.5. So from the midline to my maximum, or from my midline to the minimum, should be a total of 1.5 units. Let's look at our curve. Is this 1.5 units from that midline to the maximum? Yes, it is. What about from my midline to my minimum? Is that 1.5 units? Yes, it is. Okay? Something else you need to know is that your amplitude is always positive, okay? So say, I don't know, for some reason you end up with a negative number, that should kind of signify that something happened, something went wrong, okay? But it should be a positive number, okay? It should be a positive number. Now, to find the equation for your midline, because your midline, again, is a line, which is always in the form of y equals a particular number, all you do is you take half of your maximum plus your minimum. Okay? So in this particular example, our maximum was 1, and our minimum was -2. And so what's half of 1 plus a -2? -1.5? -1/2. You said 1.5. So it's going to be -1/2. So the equation of our midline is y equals -1/2. Take a look at our graph. Didn't it cross? Wasn't our midline at -1/2? There you go. Sometimes they won't always give you a curve, or never mind, sometimes they'll give you a curve, but they won't always show you where the midline is. But you can find it using this formula right here. Okay? And then, of course, you can always find your amplitude by using this formula of 1/2 max minus. Yes, ma'am? That number is basically used to tell us exactly how high up and how low are our max and min from that midline. questions? Now, so far, pretty simple concepts. You got the period, you got midline, and you got the amplitude. Alright? Let's look at a real world example here. It says sound waves. Sound is produced, sound waves, that's a prime example of a periodic function, okay? Prime example. Sound waves, sound is produced by periodic changes in air pressure called sound waves. What is the period, amplitude, and the equation of the midline of the bottom graph in the digital wave? Can you guys see this bottom graph? The bottom one, okay? What I want you to do is I want you to try to answer this, okay? I want you to try to figure out what is the period based off of, how we did it before. I want you to try to find the amplitude and the equation of the midline. If you can't find all three, try to find at least one of them, okay? Let's see how we did, okay? Since this was a periodic function, our period is where it completes one full cycle, okay? Or where the graph starts to repeat itself. What you guys come up with? 0.00. Careful. If you were to start, say you were to start here, okay? I just have to get back to that same spot before I start to repeat myself. So I would go down, I would go over, and I would go up. This is not one complete cycle right here. This would make one complete cycle. From this point to this point. Because think about what's going to happen right after this point. You're going to go down again. You're going to start to repeat the cycle. So that is actually one full cycle. So that point was at 0.005. This was at 0.1011. So it should be 0.0066. That should be your period. The amplitude is 1/2 your max minus your min. What was your maximum value? -1/2. And what was your minimum value? -1. 2 negatives make 8. So this is basically half of 1/2, which is 1/4. So our amplitude is 1/4. So wherever our midline is, it's just 1/4 above and below that line. Let's find our midline. It's the equation y equals 1/2 your max plus your min. So that's -0.5 plus -1, which is a total of what? You say negative what? 1.5? And so what's half of -1.5? So y equals -0.75 or -3/4 is the equation of our midline. Questions? Let's look at the last ones. Okay?
Where did you find the -0.5?
The first one is a periodic. Yes, if so, what's the period?
6.
The period is 6. The scale goes by 2s. Okay, so right here you're at -1, and then you go one full cycle all the way up to 5, so that is a total of 6. What about the second one? No. If you notice, it's starting to decrease in y values, okay? It's not bounded between a top value and a bottom value. What about the last one? This one is periodic. This one is periodic. Because if you look, I start at one particular y value, I think that's 0. I go all the way down to -4. I go back up to 0. Yes, I dip down, but I still go back up to 0 and then back down to -4. So it is bounded between two particular values, 0 and -4. What's my period? 3. Okay? So you gotta be careful with ones like that. If they're bounded between two particular values, they're not changing y values like it was in the second one, then it is periodic.